All right, let's talk about a term you hear absolutely everywhere these days: machine learning. We're going to demystify it, break this whole thing down into three simple, fundamental ideas. Think of them as the three core plays that power everything from your Netflix queue to major medical breakthroughs. So let's just dive right in.
Let's start with something we all see every single day. How in the world does your inbox just know how to filter out all that junk mail? I mean, there isn't some poor soul reading every single email, right? The answer, and you've probably guessed it, is machine learning. And no, it's not magic. It's just a totally different way of thinking about programming. So, how does this new way of thinking actually work? Well, with traditional programming, a human, a person, has to sit down and write explicit if this then that rules for every single possibility. It's super rigid. But with machine learning, we completely flip the script. Instead of feeding it rules, we feed it data. Tons and tons of examples, like thousands of emails that are spam and thousands that aren't, and the machine learns the rules for itself. It actually discovers the patterns on its own. And that, of course, brings us to the big question. What does it really mean for a machine to learn? Well, it's all about learning from examples, pretty much the same way you and I do.
Okay, so a huge chunk of machine learning is what's called supervised learning. And honestly, the best way to think about it is learning with a teacher. We give the algorithm a whole data set where all the answers are already labeled. For example, we show it thousands of pictures, each one labeled cat or not a cat. And after seeing enough examples, it starts to figure out what a cat looks like on its own.
Now, here's the cool part. Even though machine learning sounds incredibly complicated, almost everything it does, everything, boils down to just three fundamental techniques. You can think of them as the three core plays in the entire ML playbook.
And here they are, our big three. First, you've got regression, which is all about predicting numbers. Then there's classification, which is for sorting things into different buckets. And finally, you have clustering, which is all about finding hidden groups in your data that you didn't even know were there. Let's break each one down.
First up to the plate is regression. This is the play you're going to call when your goal is to predict a specific number, something that can change along a continuum. Basically, regression is all about finding the relationship between different bits of information, so you can answer questions like how much or how many. It's all about forecasting a specific value on a spectrum. And you see this stuff everywhere, probably more than you even realize. Trying to predict a house price based on its size and location? Yep, that's regression. Trying to forecast what a stock might be worth next month, or even just estimating when your pizza will arrive? All regression. Of course, it's not a one-size-fits-all deal. There's a whole toolkit of different regression algorithms, like the ones you see here, and each one is good for different kinds of problems. Okay, let's move on to our next play.
Our second fundamental play is classification. And if regression was about how much, then classification is all about which one.
Yeah, classification algorithms are all about sorting. They take a piece of data and assign it to a specific, predefined category. So the output isn't a number on a spectrum, it's a label, like spam or not spam. It's one or the other.
And the applications here are just incredibly powerful. We already talked about spam filters, but this is also how a system can help a doctor classify a tumor as malignant or benign, or how your bank can instantly flag a credit card transaction as possibly fraudulent. It's all about making a choice between different categories. And just like with regression, there's a deep bench of players here. There's a whole toolkit for classification with different algorithms, like logistic regression or random forest, that are built to handle all sorts of different challenges.
All right, for our third and final play, we're going into some really interesting territory. This is where the machine starts to explore all by itself, without a teacher looking over its shoulder. We call this unsupervised learning. And unlike the other two, we don't give it data that's all neatly labeled with the right answers. We just hand the algorithm a massive, messy pile of data and say, go find something interesting. It really is like being dropped into a brand new city with no map, and you have to figure out where the different neighborhoods are on your own. The main tool for this is called clustering.
So what can you do with this? Well, a lot, actually. A company like Amazon can use clustering to discover different types of customers, or segments, so they can do way more targeted marketing. It can also be used to automatically group thousands of news articles by their topic, or to spot weird, unusual activity on a computer network that could signal a security threat.
And yeah, you guessed it, there are a bunch of different clustering algorithms, like the super popular k-means, that help find these hidden patterns in all sorts of ways. So there you have it. Those are the three big plays: predicting numbers, sorting data, and finding hidden groups. Okay, so now that we know the plays, how do we actually, run them? Machine learning isn't just about picking an algorithm and pressing go. It's a whole process, a systematic workflow.
And here's the part that just might blow your mind. The vast majority of the time, I'm talking a staggering 70 to 80%, is spent just gathering and cleaning the data. Why? Because you can have the fanciest algorithm in the entire world, but it's totally useless without good, clean data. It's that old saying, garbage in, garbage out. It has never been more true than in machine learning.
The whole thing follows a pretty clear, repeatable process. First, you have to define your problem. Are you trying to predict a number, sort something, or find groups? Then comes that huge, time-consuming data prep step. After that, you split up your data, pick a model, and train it. Then, and this is super important, you evaluate how well it did. And based on those results, you tune it, you optimize it, and you probably repeat that whole cycle a few times. Right, and that tuning step means you have to deal with some tricky concepts. You've got to avoid something called overfitting, which is where your model basically just memorizes the data you gave it, but it's useless on new stuff. And you have to avoid underfitting, where your model is just too simple to find any useful patterns at all. It's a real balancing act, and you adjust it using these little settings called hyperparameters. Think of them like the knobs and dials on your algorithm.
Okay, so let's boil all of this down. If you're going to remember anything, remember this. 1. Machine learning is about systems that learn from data, not from a human writing a bunch of rules. 2. Almost everything it does comes down to those three core plays: predicting numbers, sorting into categories, or finding hidden groups. And 3, it all happens inside a structured, data-heavy, and repeatable workflow. We've covered a ton of ground, but believe me, we've really only scratched the surface. These simple ideas are the building blocks for all the incredible AI innovations we see popping up all around us. So I'll just leave you with this question. Now that you know the playbook, what kind of real-world problem would you want to solve? Something to think about.